Hello, under this discussion we'll be talking about using a calculator to evaluate the secant inverse, the cosecant inverse, and the cotangent inverse. So what's different between this and our last discussion is that they're not special angles. That's what they're going to be. They're not. So therefore, when you take the inverse trig functions of these, you'll need a calculator to do them. Now, again, though, is like, well, I still don't have a secant inverse button on my calculator. So you're like, well, how do I do that? Well, if you want to find a secant inverse, you need to invoke the cosine inverse. If you want to do a cosecant inverse, then you're going to need to invoke a sine inverse. If you want to do a cotangent inverse, you're going to need to invoke a tangent inverse. It's quite simple, but let's begin with this example, actually. So we want to do a secant inverse of 5. So let's look at that. Secant inverse of 5 is the same thing as the cosine inverse of 1/5. So you notice I invoked the cosine inverse. The question is, there is a lot of stuff missing between the left side to the right side. How in the world am I supposed to know that the secant inverse is the same thing as the cosine inverse of 1/5? Well, think about this. If you let secant inverse of 5 be theta, then you move the secant inverse to the other side, then you get secant of theta equals 5. Now I'm going to invoke the cosine equivalent. If secant of theta is 5, then cosine of theta is 1/5. And then move the cosine back to the other side, and you'll get cosine inverse of 1/5. So what you're seeing here is going to work for anything. So if you do a secant inverse of x, then that's going to be the cosine inverse of 1 over x. Now, I say it works for anything. It works for anything that fits in its domain. That means if you do a secant inverse of 1/2, it won't work, because what happens is you would end up doing a cosine inverse of 2, because the reciprocal of 1/2 is 2. And then the cosine inverse of 2, if you try it on the calculator, will give you something undefined. And the reason it's undefined is because 1/2 on secant inverse is not in the domain. Remember, to apply a secant inverse, the absolute value of x has to be greater than or equal to 1. That means it's got to be more than 1 or less than -1. So you can't put any number in that's in between -1 and 1 in the first place. So when I say you can use, this works for anything, it works for anything that's in its domain. And 5 is definitely in its domain. So secant inverse of 5 is the same thing as the cosine inverse of 1/5, and this is the matter of using your calculator, 1.37. Now, a cosecant inverse of -4/3. Now, the same thing with the secant inverse. The cosecant inverse has to be more than 1 and less than -1, and that does. -4/3 does fit that bill. So cosecant inverse of -4/3 is the same thing as the sine inverse, because that's the reciprocal of cosecant is sine. So the cosecant inverse of -4/3 is the sine inverse of -3/4. So like I said, it's very, very easy. You just take the reciprocal of both of them, basically. So sine inverse of -3/4 and apply it to your calculator, that's 0.85 radians. All righty? So that's going to be the cosecant of inverse. And you know something? I think there's a mistake there, because I'm believing it should be a -0.85 radians. So you might want to definitely write this page down make that correction for me. It's a -0.85 radians, because I put that in our calculator just in my head. I just put it in my head. That's not 0.85 radians. I think the sine inverse of 3/4 is 0.85. But this is negative, so it's going to be in the fourth quadrant, so it's a -0.85 radians. So definitely write this page down in your notes and make that correction for me right here. So you might want to pause for a second and do that. Now on the next one, cotangent inverse of square root of 3 over 3 is the same thing as the tangent inverse of the reciprocal of that, which is the square root of 3. And then again, you got the tangent inverse button on your calculator, and it's 1.05 radians, and I think that one is correct. So that's how you would do it. So basically, the secant inverse, the cosecant inverse, and the cotangent inverse is equivalent to taking the reciprocal function's inverse of the reciprocal of its input. So in other words, cotangent inverse of x is equals to the tangent inverse of 1 over x. And so here you just have to make sure, and again, if you do get something and you punch it into the calculator and it says domain error, what's happening is the original number is not in the domain to begin with of the inverse trig function. So if you get a domain error, that's really what's happening. So they're basically asking you to do something that's impossible to do. And so that's the only time you got to make a correction there. Alrighty. So that concludes this discussion. Again, remember to make that correction for part B for me to negative 0.85 radians. And if you have any other questions, you let me know, and you have a good day.